Chapter 15, question 4, says stearic acid and linoleic acid each have 18 carbon atoms. These are both fatty acids. Why does stearic acid melt at 69 degrees? So that's really high. Room temperature, degrees Celsius. Room temperature is 25 degrees Celsius. So you really have to heat that up in order to melt it. But linoleic acid melts at -5 degrees. That's pretty low, that's pretty cold. 0 degrees Celsius, water freezes. In other words, it takes a lot of energy to melt stearic acid, and so it tends to be a solid. Whereas it doesn't take very much energy, it doesn't take a lot of heat to melt linoleic acid, and so that, at room temperature, would be a liquid. Already, we should see that the difference between these is probably that one is a saturated fatty acid, stearic acid, and the other is an unsaturated fatty acid, linoleic acid. But the question says to use table 15.1 below, and so let's do that. Here's 15.1 here. Let's look for stearic acid and linoleic acid. So first one, I see stearic acid right here. You can see that stearic acid is a saturated fatty acid because in this whole carbon chain, there are only single bonds. The other one we were looking for was linoleic acid. So you can see here, linoleic acid is here. And notice in this one, this fatty acid has 2 double bonds, and so it's unsaturated. And because it has more than one double bond, it's polyunsaturated. And so now we can see the implication of this. So we have stearic acid, let me actually this, stearic acid, and then we have linoleic acid. So we saw stearic acid is saturated, and linoleic acid is unsaturated. If you are saturated, then the single bonds will all rotate so that each individual fatty acid lines up really well with the ones around it. If they line up well, then you have a lot of London dispersion forces. We talked about this in question 3, but remember London dispersion forces happen it's this attraction right here, when all the electrons for a fraction of a second are on one side of an atom, and on the one side of an atom on 2 adjacent atoms. So the slightly negative side on one and the slightly positive side on the other attract each other. But in order for that to happen, the atoms have to be really close. And so if stearic acid molecules are lining up really well, those atoms are going to be close, so they'll have a lot of London dispersion forces. And those attractions, those London dispersion forces, are going to make it be a solid at room temperature. And have a high melting point. Linoleic acid is just the reverse. It's unsaturated, and so linoleic acid molecules don't line up very well. The double bonds can't rotate, and so you'll have chinks in the chain where you have, say, a cis double bond, and then the rest of the chain will poke out, and they won't be able to line up very well. If they're not lining up very well, then 2 atoms can't get close like this, and you won't have as many London dispersion forces. And if there aren't as many London dispersion forces, then it'll be easier to rip the molecules apart. In other words, it'll have a lower melting point, and it'll tend to be a liquid at room temperature. So that's why, even though both of these molecules have the same number of atoms, one is a solid at room temperature and the other is a liquid at room temperature.